Hey everybody, let's start combining our skills, analyzing different types of components. So you already know how to analyze op-amps with resistors, and you know how to analyze capacitors. So now let's start combining op-amps with resistors and capacitors, and then we'll save it for future semesters if you start mixing in inductors and other types of components. So this is a very common type of circuit called an integrator, an integrating amplifier. So let's try and solve for the output over here. So the output voltage, let me label it. So this is the output voltage with respect to our reference. Let me put some more labels. I'll call this Vn with respect to here, Vp with respect to here. And let's see, there's current. I'll label the current here, IN, current here, IP. Okay, all right. So what do we do here? Let's use KCL at this node right here. And you can go positive going in, positive going out of the node. It doesn't matter. So how about I'll go positive going in. Okay, so the current over here this way would be Vs minus Vn over Rs, right? That's the current here. And then the current here that's going out, so that'll be minus In. And then the current over here is through the capacitor. So what's the current through the capacitor? C dV dt. Let me label, the voltage would be here across the capacitor. I made the current this way, right? So I'll label the voltage that way. Okay, so this is the current through the capacitor, and that's it. Okay. And now let's make some assumptions for an ideal op-amp. The voltage here is the same as the voltage here. Vn equals Vp. And then also for an ideal op-amp, the current going into the inverting input, current going into the non-inverting input, they're both 0. Okay, so this is for an ideal op-amp. So for an ideal op-amp, this is 0. Vn equals Vp. And Vp for this particular example is tied straight to ground. For this example, not always. So for this example, this is 0. Okay, so this is 0. And then, great, because if you put a source over here, it'll be different. Okay, and then see, I labeled this VC. This over here is the voltage across the capacitor. But what is that voltage across the capacitor? The way I labeled it, I put the plus sign on this side. So this side is more, this side is less. So the way I labeled it, VC is V out minus Vn. Okay, and then this goes here. d by dt of the voltage across the capacitor is, for this particular example, this was 0. Even if it were not 0, like say we put a source over here that's constant, then this would be constant, so the Vn would be constant, and then if you take a time derivative of a constant, it would still be 0. Okay, so this would be 0. Okay, so then this can go here. So let me just rewrite everything. Vs minus 0 over Rs plus feedback capacitor dV output. Okay, now let's solve for the output voltage. Let me move this on this side. Okay, and then I'll move this over here in the denominator. All right, and let's do separation of variables. So I'll move dt here, and then we can integrate. This is all constant, so I'll take it out of the integral. So from t naught to t, from v at t naught to v at some t. All right, so integrate this. Equals, and then here. And there you go. Right, now we can move this on that side of the equation. There you go. Okay, so that's the voltage, the output voltage. So let's take a look at it, right? So then let's see what the signal would look like. Let's say you had, say this were 0, right? Then right here, that would be 0. All this would be 0. So then let's, just for simplicity, let's say the output voltage at t equal to 0 is 0. Okay, so then so let's say when this is 0, the output voltage is 0. But now if we give it some kind of positive voltage, what would happen on the output? Right, if this is positive, then there's the minus sign, and then all of this. So it'll be proportional to something like this. Right, and then if we go back down to 0, then what will happen? This will be 0. So then this will no longer be 0. So it would look like this. Right, and then if we, let's say, go this way here, what would happen? It would look like this. Okay, so, and then if we go back to 0, like this. So basically, this is an integrator, right? Because let's go backwards. The slope of this, I mean, it's an inverting integrator. If we go backwards, what's the derivative of this? Negative some number, and this is positive some number. What's the derivative of this? Some positive number, and then this is negative. So, right, it's an inverting integrating amplifier. Okay, so focus more on the method more so than the answer, because in that way, whatever circuit you encounter, you know how to solve it and analyze. Okay, so just give a few of these a try and let me know if you have questions, and I'll see you on the next video.